This video is a brief overview of a BYU Idaho senior engineering project, which was sponsored by the Mechanical Engineering Department at BYU Idaho and mentored by Seth Martin and other engineering professionals. Our project was a prosthetic utensil holder. BYUI is interested in helping the disabled community. It was up to the team to identify a need and engineer a solution. We observed many unique challenges, brainstormed ideas, sought mentor feedback, and narrowed in on creating an affordable, universal prosthetic device to assist in holding eating utensils. We were working with a budget of $300 and April 4th as our deadline. From our observations, we found that one of the most difficult tasks for people lacking upper extremities is cutting meat and other foods. Traditional prosthetics require special fitting and can be expensive. In our research, we did not find another product similar to what we envisioned creating. Our current prototype includes a secure bicep strap, a 3D printed thermoformed socket, a BOA lacing system for securing the socket, angle adjustable utensil holders which can secure a fork or a knife, a mechanical 3D printed rotating wrist mechanism, and a detachable lanyard to actuate the rotation. At the start of our project, we used a table to break the envisioned device down into individual functions. We then brainstormed designs for each component. Later, we generated 4 system-level concepts and sketched them out. From there, we designed and built a simple first prototype. This prototype showed that thermoforming a 3D printed flat shape is a viable option for creating a custom fit socket. We also learned that we were going to need a way to rotate the fork from the blade up to the user's mouth. Pictured are a few prototype iterations. As you can see, the socket increases in complexity and the wrist mechanism and utensil holders are refined. Also shown next to prototype 4 is the attachment point for the lanyard. The rotating wrist mechanism was designed as a 2-part piece that could be 3D printed as one to eliminate the need for a bearing and assembly. The part was printed from PLA, which can shrink up to 2%. We conducted a tolerance analysis for each critical dimension to ensure that after printing, there would be a sufficient gap to enable rotation. As for build practices, most of the components were 3D printed, heat set threaded inserts were used wherever possible, and the hardware was standardized. Thumb screws were incorporated to ensure that the utensils could be changed without the use of tools. This video shows the socket being fit to the user. The water was set to 180 degrees Fahrenheit. After a few seconds, it was cooled to the touch, and after cooling, it was set to its new shape. Most of the user needs were met. He indicated that the device was comfortable, lightweight, easy to put on and take off. He did, however, report that there is a learning curve and it may take more practice to use the device effectively. Overall, he was very happy with the final prototype. We were satisfied with the cost as we estimated the price to build another one would come in at under $30. These videos show the 2 use cases for the device. We were thrilled to see that he could use his left arm for the first time to assist with eating a meal. In conclusion, we found that this device has the potential to be an effective low-cost prosthetic tool to assist a user while eating. The thermoform socket is a simple custom-fit interface with a lot of promise. The rotating wrist mechanism is intuitive and does not require much force to operate. In the future, we would like to improve the socket design and make it more secure. Also, possibly making several shapes and sizes to increase the universality. We would like to explore other thermoplastics to increase the strength of the 3D printed parts. Thank you for taking the time to watch this video to see what we were able to accomplish this semester.